All right, so welcome everyone to the August 2021 Trees Around the Globe Student Research Can webinar. This is a kind of encore of the webinar from July 20th, 2021. But we did this because we had 4 breakout sessions, and we're gonna have 4 breakout sessions with this one as well. But we only had time for people to choose 2 of them at the last one. So those of you who are returning with us, you can gladly go to ones that you've done before if you want more information, or join, the other 2 for the day. So what I'd like to do now is to just, go over some of the introductory metrics, and then we're going to talk a little bit about some of the upcoming missions and programs and ongoing ones as well. Each of us on the campaign team will do that like we did last month. And then we will jump into the breakout sessions where we will spend anywhere between 15 to 20 minutes per breakout session. And then we will come back as a group to the larger room and have any final discussion. And we are also, please note, we are working on getting a campaign extension for this campaign. We haven't heard back from GIO yet, but hopefully very soon. But we will be having a September webinar, and we don't have that date finalized yet because there's a lot of moving parts right now. So, but please stay tuned for that. We will get emails to you when everything is good. We will have it up on the website as well. So I'm starting off this picture here. This is a really cool picture that I took at Yosemite National Park last weekend. This was at Washburn Point. And I just thought this was a really cool picture. You can probably see my son standing there on the one rock, but this one really shows what a great expanse and amazing land cover you see here in this shot. So you can see lots of different variety of trees, grasses, shrubs. You got the barren rock, so you have lots of stuff going on there. I didn't know if Peter, if you want to do a quick glance here and mention anything to anyone about this picture. I'm kind of throwing you on the spot here, but this is your forte here.
Exactly. And Brian, I decided to jump into that environment. And so behind me, you actually see one of the giant sequoia trees that are in this area. And what I want to point out is one, Brian, you did a great job. We see, bare rock as a big part of this landscape. We also see a steep slope. And one of the things that I notice when I look at a picture like this is actually the standing trunks that are out there. And that, when I look at that, I go, oh, what might have caused that? And in this part of the world, most likely what caused that is fire. And so we actually can see a post-fire landscape here and evidence of that fire. And another place that I notice is, there's this group of trees that is a little bit to the left of your son there, Brian. And you notice those branches go all the way down to the ground. And this patch of, that patch of trees right there seemed to survive the fire pretty well. In contrast, you actually see the 3 really tall trees just to the left of that. Yeah, right there, Brian, or left there. And you notice that right around that, you see all of a sudden there's a lot of trunk, and then there's the top of the tree. And that actually is evidence, again, of that fire burning up and not getting up into the crown of the tree. And so, here we had a really pretty high severity fire that clearly removed trees that were of similar height. And you can tell because of those standing trunks that are there. And yet there are these potential seed sources to get the forest actually regrowing. That's where the future forest will come from, is those small little patches that happen to survive that fire. And so when we think about the process of fire, and many of us are experiencing that right now, it is important to recognize that we can understand the past by looking at trees that are there today. And importantly, those become the seed sources to allow the forest to recover. And one of the things that when I look at a landscape like this, part of that for the recovery towards a treed landscape, again, you have this shrub component that comes in. And that actually makes a perfect environment for those tree seeds to take hold, to get some moisture, to actually be protected from the sun for 10, 15 years before they actually get tall enough that they get above that shrub canopy. And so, this will be a really interesting place to monitor for the next 10, 15 years to see how long does it take for those trees to actually get above that shrub height. And Brian, maybe you can tell us, how tall do you think these shrubs were when you were there?
Oh, just the shrubs around the barren rocks?
Yeah.
They were, I think the tallest I saw in this section might have been just a couple feet tall at some of the spots. Yeah.
Yeah, it's really interesting because I was in another area here in Oregon, and the shrubs that were around me, 6 feet tall.
Wow.
And that had occurred in about 3 to 4 years after the fire. And so shrubs usually are one of the first things that can come in after a fire in these Mediterranean landscapes. And in fact, those shrubs are growing from roots that have been there for sometimes thousands of years. And so when we think about Greece and the fires that are happening there right now, that's part of that landscape. And many of these trees and shrubs are fire adapted. They're used to this. They have thick bark like this sequoia behind me, or these fir trees. So pay attention to some of these cues and these characteristics of the trees and the form that they are growing around you, because they can tell us something about the past and maybe the future. Again, seed trees, those are the future where the forests are going to come from. Excellent. Thanks, Brian. I love going on virtual tours to places like this, because it's amazing what a photo like this can tell you about that landscape.
That's excellent. Thank you, Peter. And that is why Peter is the NASA Globe Observer Land Cover Science Lead, everyone. So, Bo, did you have a question for Peter? You can go ahead and unmute yourself if you like. I saw your hand raised.
So I'm reading about the shrubs, and I didn't know that they had deep roots in the Mediterranean biome. But I also was reading that if the shrubs take over, it's bad. Is that a certain kind of shrub, or is that these shrubs are related to the seeds from the trees?
Yeah, so it depends on where you are. In most cases, shrubs are kind of this intermediate stage between grass or bare ground and a treed environment. And so when we think about forest succession, usually we start with bare ground, and then grasses come in and they start adding nutrients to the soil, and they can get going really fast. Shrubs sometimes will take a little bit of time. Sometimes they start from seeds. In our California area, a lot of them are fire adapted like this. And so the tops will burn off, but those shrubs have been there for thousands of years. And that to me is kind of incredible, this idea of old growth shrubs. But then, a lot of times the trees will be able to get and start shading out those shrubs. And so it really depends on where you are in the world in terms of how those shrubs interact with those trees, and do they actually keep trees from growing in that area, because maybe the shrubs actually will do something to the soil and make it less inviting for trees to be able to take hold. There's a whole chemical warfare thing happening in that soil. So it's not a straightforward story. And one of the things that we don't see necessarily here is the climate, right? And so when we think about the trees that are really tall there in the middle of the photo that Brian highlighted, those trees have been growing probably for 80 to 100 years, just kind of, at least, And if we think about the climate that was started when those were seedlings, it was a very different climate. I mean, we just found out yesterday from, a lot of scientists, 1900, it was about 1.5 degrees Celsius cooler in some places. And so that environment is very different than the trees that are starting to sprout today, right? And so keep that in mind, because the forests of the past were related to the climate of the past. The forests of the future are going to be related to the climate of the future. And they may not have as much rain. They may not have the rain when they need it. And so we actually might start seeing tree height globally start decreasing because of the extra stress that these trees might be experiencing. And shrubs or other plants can actually produce stress on tree seedlings and that inability for a tree to become the dominant part of our landscape. So, this is where our monitoring and this effort that we're doing together in this Trees Around the Globe campaign is vital. And we won't really know some of these things until we look back at our globe data in 5 or 10 years. Is this the new landscape and those trees will never come back? Or do we start actually seeing trees starting to take shape and come back to kind of this type of environment that many of us have tried to protect, because it is something that's unique and is a rare place on the world, like the sequoias, trees, and like this environment that we're looking at here in California.
Thanks, Peter. Bo, do you have a quick comment or quick follow-up?
Yeah, I just been looking up for Glasgow because I'm pressed for Glasgow. There's a huge amount of globe classrooms that could be studying this with Greece and with other people in Siberia and other places that are experiencing problems with fires and weather changes because they think that the current that goes by that warms up Scotland and Ireland has changed because it's flooding also, and the Farset is overflown in Belfast. So if people would like to talk about this, we're starting a fire curriculum between amongst many of us and bringing back materials and bringing in new CO2 sequestering materials. And this soil versus weather versus trees is a great thing to start on. And so I want to start a collaboration somehow betwixt and between us, because I want to deal with kids feeling resilient and being able to think their way through this or help evacuate, because I found that CAL FIRE has immediate information. NASA has long-term information. Peter and you can teach us how to look at things with the Earth Observer.
Thank you, Bo. All right, so here we are. This is always our shareable, but this is where we are right now. This is the follow-up, I shouldn't say follow-up, the encore of the webinar from last month. This is considered session 2. So I'm gonna move a little quickly through here. I like to always share some strange tree that I find when I'm looking around things, and this is called the Quiver Tree. And this is South African native, and you can see here that this, and Namibia, and this is a really odd tree because it says it's quite prevalent today. I don't know if anybody on the call has ever seen one of these in person, but it's on the International Union for Conservation of Nature list as a top 10 species expected to be the most heavily impacted by climate change. And at NASA, that's what we do. We study climate change, and this is one of these indicators of climate change is this type of tree. And you can read a little bit about that here, but I just thought it was a very interesting tree. And when you see these interesting trees, you always are able to Google some just amazing photos, whether it be, at sunset, sunrise, or whatever, as you can see here on this bottom right picture. I just wanted to show you that, just kind of a teaser as we jump into the webinar. So here's our campaign team, all of us. And then here's today's webinar agenda. After the introduction and some metrics, we will be talking about some NASA upcoming missions and programs. Sorry, I didn't add the word programs in there. And then we will have the breakout rooms. You have 4 to choose from, and those I'll open those up after our some of the presentations that our teams doing. And then we'll jump out of those first breakout rooms, and then we will jump into a second one, and then we'll be back to the main room for a discussion. So let me move this thing here. All right, so a little bit of the metrics, and I'm gonna call your attention down to the bottom. This is the full campaign metrics so far since September 15th, 2018. We have over 38,000 tree height measurements coming from over 16,000 global sites, over 22,000 land cover measurements coming from over 15,500 sites, and over 21,000 greenings or green up, green down measurements coming in from 618 global sites. And here's where they're all coming from. They're all over the place. But then you can see we've had tons of webinars, and I do these metrics because not everybody has a chance to be at every webinar. So I like to update these each time. But, the bottom line is that, as Peter mentioned before, we're looking at the globe data over time. We look at change over time. We look at those numbers and, the numbers, and, we can look at the same trees over time. We look at the same land cover over time, which is super important because that's how it helps us understand change. So, since the campaign started with the protocols that we have as the major ones of the campaign, we have 82,485 measurements from over 32,000 global locations during the span of the campaign so far, which is just under 3 years. And we started September, as you see, September 15, 2018, which is just over a month away. So, there's a lot of data out there, and we reinforce this because we need that data. I've heard a couple of my colleagues, at NASA say, and I like to reiterate this is, data is great, but the data doesn't mean anything unless you use it in the real world. Okay, it doesn't. If you can't make sense of the data, you have to make sense of it for it to have meaning. It has to be part of the real world. You have to be able to apply it. That's why all the NASA missions, missions from all different, space agencies around the world, they all have objectives. They all have, applied sciences. They have applications. So what this data is used for, the satellites are great at taking data. The instruments are great at taking data, but the people on the ground have to make sense of that data and apply it to the real world. So that's why I show this, because there's a lot of data out there for students and teachers and even citizen scientists who want to go to the next level to analyze the data and make sense of it in the real world, with help from things that we do as part of the campaign, with help from online tools, online platforms, visualizations, all these things. So when you put all these pieces of this jigsaw puzzle together, you can really come up with some, great ideas and great scientific research. And we are finishing up year 3, and this is a scaffold that we show at each webinar. We are in August 2021, so we are, this is the end of the 3rd year. So stay tuned for upcoming information for possible extension. And I like to point people to this Globe Trees Family Guide. And this family guide is super exciting because it allows you to, not just take tree height observations or even land cover observations, but it can bring you deeper into understanding what trees mean, what land cover means to local environments, to global environments, to climate change, all of these things. We have all these different missions looking at the Earth in different ways. We have, we add kind of the STEM stuff here, but we also add STEAM. We add art into it. You can, create, poems and, write in your scientific journal all about trees and land cover and things like that. So, and we have them divided into age groups all the way from, the youngest of sprouts through seedlings and saplings, which brings you all the way through adults. So, and as these journeys, progress throughout the years, throughout the year of the learner, okay, they get a little more complex and complicated with the materials that we're asking to do. We're asking them to ask, learn, observe, and create. So please visit that, if you haven't already, or if you have, go back and check it out again, because there's some great stuff on there. And finally, before we break up into, some of the individual presentations, I just wanted to show you this. This is really cool. This is a General Sherman tree that I was able to visit at Sequoia National Park, and I was texting with Peter Nelson back and forth a lot when I was out of the park, because there's no signal in the middle of the park. So I had to wait till I got out. But one thing I wanted to show you that was super exciting is that I was able to measure the height of this tree, and with the NASA Globe Observer, the trees tool. And what's super exciting about that is when as you use the trees tool to measure the height of a tree, you have to hold the phone at eye level, right? And you have to, angle your phone to the base of the tree and then angle your phone to the top of the tree. The problem is, if the tree may be too high and you're not far enough back, the phone ends up being parallel to the ground surface like this. Therefore, the app will warn you invalid angles. So it will not be able to do it. And I was sweating as I was doing this because I kept on moving my phone, to look at the top of the tree. And I couldn't go any further because there was a fence behind me. So I was actually standing on the ground, kind of leaning against the fence to get as far back as I could. And then I was able to get it. And I measured it at, it says 83.79 meters, which translates to 274.9 feet. And then I went and I looked up on the National Park Service website, and they have it measured at 275 feet, which is mind blowing. That it was, I basically, the app measured it at 0.03% error, which, you know, with the app, you know, the taller the tree is, the more accurate it's probably going to be. But it's just a matter of, I was worried because I couldn't get back any further. I was about 75 at that max, 75 feet away from the tree, and I just couldn't go back any further. And then there were people all around, so I had to do it. So I had to show you this. This tree was just mind blowing in size, just unbelievable. And this is Sequoia National Park. It's the first time I was ever there.
Hey, Brian,
And
how
yes.
many steps did you take, you know, to make that estimate? I'm curious because, you know, here I've tried similar things, and for anybody who's tried this, you know, you get an error message if you take more than 50 steps, right?
It was around, I can't remember exactly, but I know it was in the low 30s. So it was between 30 and like 34, I believe. I can't remember the exact number, but I remember it being in the low 30s.
Yeah.
So yeah, so you know, I actually had to do it kind of on an angle because right in front, well, I walked to the base of the tree, but I had to do it. I couldn't do it straight on because, well, I walked straight on. But I realized when I was backed up to the fence that I had to shift over to the left to get it because there was a big sign that said General Sherman tree, and I would have had to step over it, which would have messed up my stride. So I made sure I had a direct path to it. Yeah. So yeah. So the last thing I want to show you here is, and I want to show you this because, you know, this is possible. It's possible to measure things this tall, okay, which is very cool. But I want to show you this picture here because at the time, you know, I sent Peter this message. I said, hey, I said I was able to measure this. And he said, hey, did you happen to get a land cover at the same time? And I said, oh, crap. I was so excited that I was able to get the tree, and I was trying to get out of everyone's way to get the tree height. I was like, oh no, I totally blew it and forgot to do a land cover right there. So I apologize for that, Peter, but I was so excited, and there were so many people waiting in line to get to the base of the tree to take a picture. So I was just super excited I was able to do it. So, okay, with that said, yeah, that's fine. So just wanted to show you that, but that's my son and I, you know, taking a selfie up from the base of the tree, looking up. You know, that doesn't do it justice, but it does show you that it's an amazingly tall tree. And I did look it up. I believe the circumference, you couldn't get directly at, you know, to get it around the tree. You couldn't spend all that time to work around the tree, but I think I looked it up in the Park Service, and it was 36. I don't remember if it was 36 feet diameter, something like that. It's something just amazingly large. So, okay, with that said, we are going to jump into the upcoming NASA missions and programs, and I will stop sharing and I will pass it over to Peter. I've done enough talking.
That's never true, Brian. I appreciate that wonderful introduction, and you know, to me, this is the excitement that we can actually have as this community. I mean, it was just great to see Brian out there getting that big tree fever. I live in the Pacific Northwest, and have spent a lot of time in California. And so, you know, actually, you know, seeing those landscapes is really important. And that comparison contrast that Brian has been able to demonstrate, you know, from the other pictures to different landscapes is an important piece. That comparison contrast is something that your students really could benefit from. And so, you know, part of what we want to do here is give you some new tools. And I want to, in particular, help you be a little bit more comfortable with satellite imagery, in particular, the Landsat time series. And the reason why I bring that up is because at the beginning of GLOBE back in 1995, 1996, the land cover protocol was developed to support the Landsat satellite mission that has been running since 1972. And I bring this up because I'm really excited, and I hope that you'll join me and get excited as well, that September 16th, there will be a launch of the next Landsat satellite, Landsat 9. And that is going to allow us to really keep tracking all of these tree dynamics that are out there. And I highlight this because there is a lot of satellite mission data and interesting things that you can use coming from this particular satellite. And again, it ties perfectly into the whole reason why the GLOBE program exists, which is in part to support the satellite missions like this. And so, in my breakout session, come join me, learn a little bit more about all of the different satellite missions, but also the data that's available to you. I'll highlight that now here in NASA Worldview is this harmonized Landsat Sentinel data. And so NASA is combining their effort with the European Space Agency to give us 30-meter data now in Worldview. And so this, as a teacher allows you and a student allows you to access all of the different data sets that NASA has available pretty much at your fingertips. And there's stories and other information, especially related to fires and land cover. But, having this high resolution imagery allows us to get a little bit more detailed. We still can't see the individual trees, but we can start to understand kind of the area that those trees are in. So I want to highlight that for you, even if you don't come join me at my session. But if you do come join me in the breakout, we can explore this a little bit more. And I want to highlight for everybody, one of our GLOBE partners has put together this Future of Forests lesson. It's a 9-lesson plan. And it really helps us to tie together some of the concepts that I was talking about. And I want to highlight this because there are 2 tools in here that use Landsat data to look at those trends over time and look at forests. How are they changing? So not just this snapshot in time, but thinking about processes and the phenomena that interact with trees in particular. And then, there's this nice lesson that you can use to tie your students to that satellite data using the GLOBE Observer. So I know that's one of those things that can help you as you're starting to prepare and think about your students. A lesson plan like this might be useful for you. Finally, I want to highlight that right now, the Landsat outreach team is doing this 9-week Camp Landsat. And this week is actually focused all on forests. And so we'll take a look at this Camp Landsat materials that they've come up with. And in particular, their story map that they have created to look at Landsat data, satellite data, which is 30-meter optical data that allows us to look at these dynamics of forests from space over 20, 30, 40, 50 years. So as you can tell, I'm excited about this one, in part because we have a new satellite that's going up that the science will only really work well if you join us in that. So that's what I'm going to be talking about in my breakout room, and I hope that some of you come and join me.
All right, thank you, Peter. Let me go back here and share my screen again. All right, so in my session, my breakout session, I'm going to talk to you about comparing ICESat-2 tree height data and the data from the GLOBE program of tree height. So, but I want to talk to you a little bit about these lasers from space that NASA has been put into space. One is called GEDI, and it's a Global Ecosystem Dynamics Investigation. It's on the ISS, and it uses, you see these lasers here. It uses this to measure the tree canopy at certain latitudes. And then we have ICESat-2. We have the Ice Cloud Land Elevation Satellite 2, which all of you have heard of by now because I've worked on that mission for probably 12 years now. And we mentioned it every webinar. It's on just like every part of the campaign website. But it uses a laser altimeter as well, firing at 10,000 laser pulses per second. So we're getting amazing amounts of data. We're getting about 1 terabyte of data back. Now, it's not all trees, of course, because it's called ICESat. So its primary objectives is to look at the ice sheets of Greenland and Antarctica, glaciers, glacial retreat, things like that, snow cover. So it does that, but because it's a laser altimeter, we can measure the height of things, where we can do lots of things like measuring tree height, potentially shrub height, cloud height. We can look at the sea surface level, the the heights of bodies of water, mountains, buildings, and everything. Mostly these static things on the planet. That one question I thought was pretty cool that came up to the project scientist, Dr. Tom Newman, one time during a Facebook Live, was someone asked if it could measure the height of a penguin colony. And he said, essentially, yes, rare, but yes, because if that penguin colony stays in the same place for a long enough period of time, you will be able to see that bump or that blip in the data if ICESat-2 happens to be flying over it. All the variables have to be perfect for it. It has to remain there, and ICESat-2 has to fly over it, and the photon has to penetrate whatever cloud cover is there and then return back to the satellite. So with that said, I'll show you a little bit more about ICESat-2. I'm going to show you this quick video real fast. And this is just a little background about ICESat-2. And then we'll go further.
From satellite data, we have a very good handle of how our Earth looks like. We can see oceans, we can see the sea ice, we can see our forest. What is much, much harder to measure is how high things are on a global scale, almost impossible.
ICESat-2 adds the third dimension, the elevation. Repeating measurements from ICESat-2 will allow us to measure changes in the ice sheets or in the ocean or in land.
ICESat-2 is designed to measure the changes that are going on in the cryosphere, in the polar regions.
All the change is at the edges. Those are the steeply sloping parts of the glacier that interact with the ocean, and that's where all the action is. That's where all the mass is being lost.
In order to estimate the mass changes, we need to know the height of things.
All right, I'm going to stop it there because I don't want to take up too much time, but I want to also mention GEDI, the Global Ecosystem Dynamic Investigation. And as you can see, it's also firing these, this LiDAR, this active remote sensing at the forest canopy, and it's looking at the forest canopy, within specific latitudes on the planet. And once again, this is on the International Space Station, so it's just part of a suite of a lot of instrumentation on the ISS. And you may have used open altimetry before to look at the ICESat-2 data for tree height. There's also, in a beta version, there is the GEDI data on open altimetry as well. Okay, not as much data as ICESat-2, but the folks at the National Snow and Ice Data Center that run open altimetry are working on that whole beta version to make sure all the data comes out the way it should be, that the data is right. So all of that is being worked on, and there'll be a probably a more permanent release coming up. And I should mention also that with this satellite data that's on like open altimetry, which I'll be talking about during the breakout session, is that there is some data latency because the data has to be processed. Right now, I think the most recent ICESat-2 data on the site on open altimetry is towards around May, which is pretty good because when they first came out, it was about a 6-month delay in this processing, but it's been streamlined since then. So it's about a month and a half or so right now. So it's looking good. So that that window of latency just gets smaller and smaller all the time with the data coming in. All right. So I will now pass it over to Peter to talk to you a little bit about ECOSTRESS. And Peter, do you want me to just keep this up here, or do you want to share yourself?
I'll go ahead and share my screen.
Got it. All right.
Thanks.
All yours.
Here. Oh. You guys see that okay, I hope?
Yeah.
Excellent. Well, once again, thank you guys for joining us. One of the things I was going to talk to you today about is the ECOSTRESS project. Much like GEDI, ECOSTRESS is on the International Space Station, and it's studying plant water use and stress. Or as the principal investigator basically says, we study plants' sweat, which is a very simplistic way of saying it, but it does a great job of doing that. So here I just wanted to thank the former PI, Josh Fisher, and his team for helping to provide these slides and all the data that they provide as well. So with ECOSTRESS, well, you can't have a really cool NASA a satellite without having a really cool time-lapse image. So I just thought I would put that in there because it just looks really cool. With ECOSTRESS, as I mentioned, it's on board ISS. It is an instrument that has a multi-spectrum thermal infrared radiometer, big word. Basically, it is a joint collaboration, the perfect international collaboration with JAXA, the Japanese Space Agency, with the Canadian Space Agency, with private companies like SpaceX and NASA, of course. So you have all these companies, all these countries coming together to put this instrument on board the ISS. And it's a perfect way of doing international partnership, which is really what we do with the GLOBE program as well. As Brian mentioned, we're starting to really put a lot of these satellites, these instruments rather, on board ISS. So now we're really starting to utilize ISS as an Earth science platform to help us understand the different phenomenon that's going on with our planet at a very low cost way. So rather than spend a lot of money putting the sky on its own platform, we can put on ISS and really get the US taxpayer dollars, really give them that really good bang for their buck, so to speak. And since it's on ISS, it's going to be at a 52-degree inclination, meaning it's going to be at the tip of South America and about the top portion of Alaska, meaning we can understand and start studying the diurnal cycle in these areas. Go to the next one. Switch. Okay. So as Brian mentioned, that we also have, with a lot of our satellites, these overarching science questions or goals. And for ECOSTRESS, here are 3 of those scientific questions that we want to understand, or better understand, rather, I should say. The first one is terrestrial biosphere. We want to understand how that responds to changes in water availability. We also want to understand changes in, once again, that diurnal cycle, the diurnal vegetation water stress, and how that impacts the global carbon cycle. And one of the last ones there is, of course, agriculture. We want to understand the vulnerability by reducing or reduce through advanced monitoring of agricultural water consumption use and improved drought estimation. There are some of the things that we're going to be studying with this satellite, with this instrument, I should say. And here is a very quick kind of a slideshow that they put together, quick animation. Hopefully it plays. And of course, now it's not going to play when I need it to. So we'll just move on. You can find that on YouTube as well. So one of the main things that ECOSTRESS is studying is evapotranspiration. And here's a quick definition of what evapotranspiration is. It is the process by which water is transferred from the land to the atmosphere by evaporation from soil and other surfaces, and by transpiration from plants. And this is very important because evapotranspiration is one of the key climate variables. So when we're understanding the water cycle, the energy cycle, the carbon cycle, evapotranspiration is one of the key components for that. So I just wanted to briefly talk about this so that when you're out there making your measurements about, tree height, land cover, clouds, and whatnot, it's important to understand other variables that you can probably put into your research to add to your hypothesis. And with NASA, we have a lot of different satellites that can add to that, that topic. So I just wanted to mention ECOSTRESS and the importance of evapotranspiration. And of course, if you want more information about the instrument, you can go to their website at ECOSTRESS there. And if you want to download that data, once again, you can find that at the link below or from the link on the website. There's some great imagery of what the satellite can do to understand different things that are going on with our planet. And if you wanted more information, perhaps we can have one of the scientists come over and give us a quick talk and really get in depth about what ECOSTRESS can do and how it can help you and your students with their research and understanding evapotranspiration. And with that, I'm going to say thank you. And in my section, we're going to be talking about how we can help you with your research and some of the different resources we have and where you can find data that can go with the things that you're studying as well. So with that, I'm going to go ahead and turn it over back to Brian and say thanks a lot.
All right, thank you, Peter. Let's pass it over to Dorian to talk about the NASA Food and Drink campaign.
That sounds good. And I'm going to put in a quick plug for my breakout room because it ties directly to what Peter was just telling us about. I'm going to be sharing how you could have your students access GPM data to be able to understand the impact of precipitation or the lack thereof on trees, not only in their area, but anywhere else around the world. So please join my session if you would like to learn about that. Let me go ahead and put this on present mode. But what I want to tell you about right now is one of my favorite parts of being in the front lines here with NASA and Earth science and learning how we take these data that we get from all of these different Earth observing satellites, including the data from the ISS, and how we can use those for real world applications. So right now, it started July 25th and will run through August 25th. There is what's called a campaign, and there's lots of ways in which campaigns can be utilized. In this case, campaign means a way of focusing on how NASA data are being used for real world applications. And we're looking at food and drink this summer. And that's NASA as a whole large organization, both JPL where Peter is and Goddard where I am, and all over the different NASA centers. So there's some of the ways in which these stories are being told. One is with a cooking show that's really fun. There's a different episode every week. Then there are farmer and community focused features, some visually driven research stories, and direct pitches to the media, trying to help them to get involved and learn more about these topics, and then some data and education tie-in products. These are the different time periods during which these stories are being pushed out. You will have access to these stories after they're pushed out. One of the things I'm working on creating is a story map resource packet that you'll be able to go to gather up and look at all of these different stories. And then you can decide when and if these stories or some of the associated videos or STEM outreach focuses that we have are appropriate for students with whom you're working and might help them to get involved and invested in collecting data in their local environment. So some of these features that we're looking at, there's one that actually focuses on Peru, which is a globe country, does a very nice deep dive into the importance of fishing and aquaculture in Peru and how they are responding to climate change, and lots of different ways in which you and the people with whom you work can better understand the people, whether they're farmers, whether they're ranchers, whether they're NASA scientists, the various people who are all involved in helping take these free NASA data and make them accessible and available to a wide variety of decision makers, as well as helping those of us who eat and drink on a regular basis, which all of us do, to understand how NASA plays a part in that. These are some of the different audiences for whom these stories and videos are being created. And we certainly all fall in here in the science interested public and professionals. This was just giving a little more information about the cooking show, which is kind of fun. It's about a 4 to 6 minute long session. And the one that came out last week focuses on ceviche, which is a lovely Peruvian dish. And it is done in Spanish with English subtitles. So if you get a chance, check that out. And here I wanted to show you, this is the website where you can find everything. I'll also put this in the chat. I'm just going to go to that real quickly and show you. When you go to that website, you see all of the different resources, videos, and so on and so forth that have been pushed out thus far. So I will go ahead and copy and paste that and stick that in the chat box. And with that, I am finished with this portion, and I will see anyone who's interested in finding ways and some resources for helping students to understand the impact of precipitation on trees. I will be happy to share that in the breakout room.
All right, thank you, Dorian.
You bet.
All right, so now here we have the breakout sessions. So we are going to jump into these, and I'm going to open these rooms in a second and then give you a minute or two to go. And we're going to probably spend about 15 minutes in each one of these sessions. So there's going to be 2 sessions, so you get to choose 2 today. If you happen to jump out of one and go to another one, that's fine, that's on you. But when I open it up, you'll go to one, and then you decide where you want to go, if you want to stay in one or whatever. But here are the breakout sessions again. GPM precipitation data and how it affects trees. That's with Dorian. Land cover and land cover change for student research with Peter Nelson. What are you doing, and how can we support you with Peter Falcon? And globe tree heights and ICESat-2 data comparisons with me. So this is what you're going to choose from, and I'm going to go ahead and I'm going to stop sharing this right now, so then I can open up the rooms. And then if you have problems jumping into a room, let me know. Tell me which one you want to go into, and then I will put you in there. But let me go and open up the rooms now. All right, here we go. You should be able to choose what room you want to go to. That's at least what I have it set up as. I'll stay in this main room until everyone has chosen.
Brian, I think you might need to put me in one.
Okay, let me do that.
Brian, I'll ask you the same thing. It's not listening to me. Thank you.
All right. Got it.
Can you go over how to join the breakout rooms again? We just self-select?
Yeah, you should be able. Is this Kate?
Yes.
Yeah. Let me know which one you like to go to. I can just assign that. I can just send you to it.
The one about the rain data, Dorian.
Got it. All right, we have a couple more. Bamigbada, do you know where you want to go? Or Salim? All right, welcome back, everyone. We are waiting. Hope that everybody had a good discussion. I know we had some great discussion in ours with ICESat-2 and open altimetry, but we will wait until everybody pops back in because there's about 25 seconds left in this. It gives the 1 minute warning and then it shoots everybody back here after that minute.
I wanted to put something in the chat window there for everyone. It's the report, the IPCC report that just came out recently. So if they're interested to find out, what the experts are saying about climate change, if they want to use that information in their classroom or in research, it's a great report to read, and it gives you some great background information about what's going on with our planet, and once again, what the experts have found about climate change. So that link is in the chat box there.
Excellent. Thank you, Peter.
I was trying to get out of my room and it ended up kicking me out of the whole thing.
Yeah, when I hit the close rooms, it gives that minute warning and it counts down, and then you're out of luck after a minute. Even if I have no control of that. If you're still talking, it's going to kick you out.
That's funny.
That's a great way to get people to get out of the rooms real quick.
You better believe it.
I do like that in Zoom, that it just, you can't have people just hover in a room and just, yep, you're done. You're out. All right, so do we have everyone back here? I believe so. All right, let me, Marcus, yes. Marcus asked, is there already ICESat-2 data available that shows results of the polar isometric range? Yes. If you just happen to go into like the ice sheets in the Arctic or Antarctic, and you can do the same thing as I showed you with looking at the tree canopies, and it'll tell you, what those photons are actually showing. So yes. All right. So now we're going to, I'm going to open up the rooms again, and please go ahead and join the one you want. And once again, if you can't jump in it, just let me know which one you'd like to go to, because some people seem to be able to and some people can't, but that's the beast that is Zoom sometimes. All right. I will hang out here till everyone is into a room. You need to assign you, Dorian. I can pop you in there.
Okay.
All right. Looks like everyone is getting there. All right, there's a couple people. All right.
Hello there.
Hello. Trying to welcome people back. And the time goes so fast in those breakout rooms. Jeez.
It does, but I'm copying this for our September mosquito mission because I just love this, allowing people to jump in and learn a little bit more about something that they find relevant to them.
Yes.
Can I just say, after this whole year of COVID, it is so rewarding to be able to interact with other educators. It's just very rich. So I appreciate it. Thank you.
Thank you.
We love hearing that. And Larissa, I put the links to, and for anyone who would like them, the GPM and trees slides there. So if you'd like those slides from my presentation, and then also you'd asked about real world applications for NASA data, and there's that I had shared.
Excellent. Thank you, Dorian. Thank you, Brian. Thank you, Peter.
Larissa.
And thank you, Peter. You just, in all the participants, I'm in awe. You made my day. You made my month. You made my year.
Oh, Larissa, you're the best. That's what we love to hear. That's why we're here.
We love you, Larissa, for sure.
And we all love you back. Absolutely. I know I can speak on behalf of us all. Thank you, thank you, thank you. You're all amazing.
That's what we're here for.
All right. So do we have everyone back? Is everyone back? I know some people had to leave because it's half past the hour. All right. So Kate, yeah, I just popped it in. Kate and I were talking about one thing I want to mention in our breakout. One thing that she mentioned, that she has a lot of her students taking tree observation using a handheld clinometer, and she asked, should I also use the trees tool on NASA Globe Observer? And I said yes. I said we actually created a classroom lesson, and that's on here on the NASA Globe Observer trees resources. It's a lesson that allows you to take tree heights using the handheld clinometer and the NASA Globe Observer trees tool. And then there's a chart created on that on the activity where you can do comparisons and figure out, errors, between those two. And then you can then take it that next step and look at the ICESat-2 data. So you have, 3 layers of data to look at that, and look at the accuracy of, each instrument, each modality of measuring tree height.
Beautiful.
Yeah, it's a lot of fun. When I first showed it to my son, when we first did it, he was 12, and he's like, great, but then I showed him now when he's 14, he's like, oh, this is cool. And then he got to go out when we went out to the big trees, the sequoias, and, all those huge pines out there, he was super excited. He was like, oh man, this is why you do it, isn't it? I was like, yes. I said, because we don't have trees like that here in Maryland. We have fast growing trees. We have super fast growing trees out here in Maryland, but just nothing of that height.
Exciting. Wonderful.
All right, with all of us back, we want to have any last minute conversation here? I think everyone's here. Any last minute conversations that anybody, or questions or comments people would like to bring up? Please unmute yourselves and go ahead. And if anybody on the campaign team, Peter, Dorian, or Peter would like to say anything else before
Sure. I think Bo is muted. It looks like she wanted to say something.
I just want to say there's youth summits happening everywhere. Scotland set a model for Northern Ireland. We had a meeting with the people at Stormont that they're starting a youth assembly, but they're starting ways to listen to youth, but the youth will need things like Globe. And so we're looking for a Northern Ireland coordinator or contact, because mostly Globe is in Scotland. Oh. And I wanted to say that it's a great way to connect, is listening to kids that have questions and want to work with all of you.
Peter Falcon, do you remember that? I can't remember his name. It's just, I'm slipping my mind. The Ireland country coordinator.
And Andy Purstill.
Yeah, but they're different countries. And so we need actually for the UK, somebody who is okayed, but the USDA works with Northern and Southern Ireland. Right. So I'm trying to just put out for, request.
Yep. But it's good to have Allison is be a good contact for sure, as being in Ireland. Yeah. Right.
I was gonna say, Larissa and I had a really good conversation. I think there's something that maybe we can address at some time. Not only about, globe and climate and policy, but also just also applied science. because we were talking about, there's a lot of people who get, they can see the data and they can understand the importance of it. And you get others that look at it and go, I don't understand that, convince me. And then you can get some that say, yeah, I may be skeptical about what we're seeing, explain it to me. And it would be great to be able to say, here's some factual information, here's some kind of like firepower. You're going to have those type of discussions to say, look, here's the facts, here are some models, here are some stuff. And it would be great to kind of showcase that to our folks here so they can go in and have those type of discussions and knowing they have factual evidence behind them.
Yeah, that's an awesome idea. And I think, in the coming year, granted our extension, that, all of us on the campaign team and others, the rest of you are here, with Globe, we can pull upon our resources of folks that we know who are in the applied sciences for many of these missions, who, would most likely be willing to come in and give, some short presentations during some of the webinars, if that sounds good, because, I know a bunch of people who are ICESat-2 folks, GEDI folks, there's Landsat folks who you might be willing to, come in here, and they can get the word directly from, those research scientists who are using that data, taking that data and applying it to very specific research studies. And so that'll help, hopefully help a little bit of that the skepticism, the questions, the I don't understand with because we do realize that there is just an insane amount of data bombarding everyone all the time. When we're talking about like ICESat-2, that's a terabyte of data a day, and that's just one satellite. Think about all the other satellites combined, and the instruments on the International Space Station combined. How do you, go through? If any of you use the NASA worldview, I know Peter has shown that many times, NASA worldview, there is a lot of information on there. It can be overwhelming unless you know specifically what you're searching for. So you can look at basically any type of NASA data and find it on NASA worldview, but that's another thing. We understand that it can be overwhelming, to those who, aren't, rooted in research, those who, are just looking for something specific, and just have a hard time, filtering through everything that's out there. So that's one of the reasons why we're here. That's what we're trying to do. That's why, Peter Nelson has done so many of the tutorials throughout the last couple of years as part of the campaign webinars that hones in on specific tools and data sets to help look, at specifically trees in certain areas, what the land cover is in certain areas and things like that. I know, Peter Nelson, if you want to, expand upon that at all.
Yeah, actually, I just put into the chat, I think a really important resource, and I'm just going to quickly show on my screen here what I'm talking about. And this is, kind of the context of why we are tracking trees around the globe, is because of this effort to understand, and this program RED+, reducing emissions from deforestation and forest degradation. And this is a program that NASA has supported, and a lot of the things that I was showing earlier are in support of this particular mission. And all of this is to understand greenhouse gas impacts. And so there are a lot of tools out there, including the ones that we brought to you here, that are being used by professionals in this context, and that your students can have authentic research experiences by using some of the tools that we brought to you today, and over the past 3 years of this campaign. And so, I'm really glad to see this enthusiasm around the topic of trees. And as we saw yesterday with the International Government Panel on Climate Change, the IPCC report, how important it is to keep track of these things. Scientists have been making predictions since 1990 about what would happen. And we need all of that data and all of this information to understand if the predictions that they just made for us are going to hold up into the future here. Or were they right? Are they wrong? Are the mitigation efforts of planting trees like we've highlighted actually helping us to reduce these emissions? Or are we actually creating more because of the impact of drought on our forests around us? Yep. Those trees that we plant today, are they actually going to survive this drought that we're planting them in? These are questions that nobody has an answer to. But there's a lot of tools and a framework that we want to help you to understand and bring to students, and to prepare the students to engage in that decision making. To that point of what Peter and Larissa were highlighting, data to decisions. That's what we want to help people to understand. It's fun. I get lost in the pixel numbers and the values and that kind of thing. But ultimately, there's actions and there's knowledge here that we all need to take and use in our community so that we can be part of understanding and tracking this dynamic Earth that we're all on. So let us know, what we can do to help you. And anybody who might have had some problems or didn't get to the session that they want, let us know. We recorded this for that reason. And I want to highlight, what has happened since we started this campaign. Maps like this have come online that have actually taken ICESat-2 or GEDI data that Brian has highlighted, that 3-dimensional structure, and combine it together with Landsat data to give that spatial breadth, to help us to understand why we have the tree height that we do here in the Amazon, and why up here in the Pacific Northwest where I am. And a map like this, allows students to maybe access and understand things in a slightly different, easier format than even what we presented earlier on in our campaign. This is the technology that's changing, and I'm excited that your students and the people who are joining us have been able to take advantage of some of these things. It's an amazing world right now with all these maps and resources that NASA, NOAA, the State Department, National Science Foundation, all these people are providing to us and to the students to have into the future. I'm off my soapbox now.
We love your soapbox, Peter. All right, anyone else? Also, please stay tuned for emails about the September webinar coming up. Our team is working on doing some planning on that and some discussion.
Thank you all. It was really absolutely amazing. And thank you, thank you, thank you. Just
Thanks for
bravo.
joining us.
Bravo, bravo.
Thank you all. Wonderful webinar.
Yes.
Thank you. Thank you, Larissa.
Thank you. Thanks a lot.
All right. Thank you, Kate.
Bye-bye.
Great job, team. Wonderful. Thank you.
Thank you, Valerie. Bye-bye.
Take care, guys.
Bye-bye.